Morning. Cool, welcome everyone. So we have nothing in the agenda at the moment, but here we go. So let's see, last minute entry. Good work, Graham. Yes, please.
Sure. So I can give a quick, hopefully demo of where I'm at with kind of restoring deployment visibility. Once I can find the right terminal screen. Let me share. Sorry, I'm a bit slow today. Okay. So I'll up this. So at the moment, I'm still experimenting with this and I've still got a couple of pre-tasks to do. So this is using like a newer copy of Helm and some newer copy of kubectl, some other bits and pieces. But at the moment, for those of you who are aware, so basically when we run Helm or we do our deployments, we look in the CI job, we just see Helm saying, I'm applying your new manifest, and then it just sits there spinning, 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 and then it just says it's done. Job's completed, and we get very little feedback as to what's going on. And I've been looking for ways to restore this and get some visibility into it. And it was surprisingly difficult to do. And I'm not even sure if I've entirely got the best solution, but I've got one solution, which is the smallest and simplest solution. So what I'm going to do, this is in the pre environment. This is GitLab value. So I'm just going to temporarily dirty the pre environment by putting a label on this, and then I'm actually going to deploy to that. So this part of the command here is just the normal KCTL upgrade, and it's this second part that is the important part. And so basically what I'm doing is I'm getting all of the deployments, and then I'm basically using this command kubectl rollout status to basically, what that does more or less is basically you give it a, a name of a resource like deployment or whatever, and it just it watches the rollout status and gives you kind of a live feed update on that. I'm using xargs to basically run the command itself. Actually only takes one resource. So I'm using xargs to basically pipe that out so we can run multiple copies of it at once. I should have actually kicked this off already because it takes a while to run. So some interesting pieces about this though, and this is going to be probably just as much or if not more work for me to do this on this issue, is to do this to work. To get this to work, we have to change Helm file from basically blocking until everything is done to just submitting the manifest, the Kube API server, and then just, exiting cleanly. So then we can fire off the next tool to actually watch the deployment. So this means we have to drop the Helm wait flag and the Helm atomic flag. So Helm is no longer like blocking on resource completion, and it's also not atomic as in that doing that automatic rollback if something goes wrong. So there's a linked issue to this, which is discussing about dropping the atomic flag, discussing about and then the second part of this. Why is it always? Might help if I do valid YAML. So the second part of this, which I can kind of get into while we're waiting for this, is basically getting out of using Helm to do the atomic, like automatically rolling back if something goes wrong, and how we still capture the capture when something goes wrong, and then either automatically rolling back or just having a mechanism where we can fire off another CI pipeline that does a Helm rollback. Java already lodged an issue discussing this. So these are all kind of linked. And unfortunately, we kind of have to go down this path if we want to actually have some visibility, because there's just no way for Helm to give us that visibility for some reason. I don't know why they took this functionality out. It's really annoying. But yeah,
Does that
so
mean, Graham, that,
sorry.
does that mean that, like, we would block in the pipeline until the rollout is complete?
Yes. So what I'm
Okay.
planning to do, so I need to do a full test of this. This is why this is a work in progress. But what the plan is if any of the, so the rollout status will watch the action, which we'll see in a minute, will watch the rollout status of the pods. And we can set a timeout on that. Well, there's two mechanisms, right? So Kubernetes deployment objects already have like a setting where you can say how long should you wait for a rollout to not progress before aborting, if that makes sense. So that's on the deployment object. And then I can also tell kube rollout status, the command line, if it takes X amount longer than X amount of time, bomb out as well. So either way, what will happen is you will see these logs from rollout status. At some point, they will actually return with a non-zero exit code. And so the CI job will fail. The apply CI job will fail. You'll be able to look at it and hopefully glean some output from what's going on. However, just because the apply has failed, what that typically will mean is now not things are in a bad state, but like, you know, let's say it's tried to spin up 2 new pods and those are crash looping. The Helm release object has got like the new code, and Kubernetes has not progressed. It hasn't taken away any pods because the new pods are crashing. They're not ready. So things are still in a workable state, but then we need to figure out how we kind of gel up the Helm release again. Like do we just do a git revert, or in the case of auto deploy, do we have a pipeline where, or like you mentioned this, Jav, like just every pipeline having a Helm rollback job that you just have to click if you're like, actually, this was, this is aborted, this is a bad idea. The other thing we could do with the Helm rollback job is we could make it like a on fail. So if the apply job does fail because the rollout status is returning a non-zero exit code, we could then automatically run the Helm rollback job, if that makes sense. So we're just kind of figuring, we're moving the logic from doing rollbacks from all inside of being managed by Helm to basically our CI pipeline.
So let's say I do a registry application upgrade and I fat finger the tag, the version.
Sure.
So
Yep.
So obviously, like, there's an image pool failure, it's a failure, and previously this would have been rolled back, but now we're in this state where you have an image pool failure. At that point, would we be able just to go forward, or would we roll back? What would we do in
So
that,
it's a
in that situation?
Good question. So 2 points for those of you who are watching the screen. So this is the actual output now you can see in real time. It's what's rollout status is giving us. It's showing us as replicas are coming online, as old replicas are going offline. So to the question, so there's 2 things to note here. One, I'm not convinced Helm is actually picking up if new pods are crashing and automatically rolling us back. I haven't seen a solid case. I think what we see now is Helm just times out. Whenever I've seen recently, and I don't know if something's changed and I need to do further debugging on this, but I'm not convinced Helm is actually smartly watching and rolling. Like, I can't remember the last time I've seen Helm Atomic actually automatically pick up a problem and roll things back. And I don't know if that's our setup, a bug in Helm, or something else, but definitely it's always had to have been us coming and killing pipe. Remember how we have to kill jobs and then Helm's in a bad, it's never just seems to pick up the problems we have of fat fingering and a crash looping pod. So in that case, so let's say Helm did do that. Sorry, I got distracted and just.
It's okay. So like I fat finger the image tag name or something.
Yeah.
So then I can just go
Roll
forward, right? Like I can just go.
You can, yes.
Yeah, I won't have to revert that change and then.
Technically no, because the replica set wouldn't have progressed. You've still got all your old pods. The auto pod, the horizontal pod auto scaler should also use the old replica set. It should be modifying that. It won't until the replica set has been marked as completed, like the new one has progressed completely, that it should be using it. So in theory, yes. In theory, there's probably never a situation where you're kind of in a bad state that you can't just keep going forward.
I see.
Really what I need to do because a lot of this is, I think, and I feel like, and what have you, I need to, as part of this issue, do proper actual testing, possibly even with Helm and also with the proposed new mechanisms to make sure we do understand both options.
Could you write this out as well, Graham, in terms of like the process? Because this is pretty similar to all the discussions we've had around deploying things and rolling them back, but
Sure.
kind of parallel. So I'd like to make sure that we bring those together and have like the same kind of responses on rolling changes out, logging those, what happens when they fail, and how we recover from that. So it doesn't have to be like an identical tooling setup, but just so that we manage those processes in a similar way.
Yeah, sure, that makes sense. Yeah, I think I've still got to kind of flesh this whole thing out. Because yeah, even just talking about it now, it's like, it sounds so simple just to restore. Basically, the reason we kind of got to go this path is like Helm used to have Tiller, and Tiller would log what was going on, so we could capture that log and put it in our CI jobs. Helm, oh, excuse me, Helm 3 lost Tiller, and thus we lost those logs. So we can't, and there's issues upstream in Helm. Please give us logging, please tell us what's going on, and they've just been brushed aside or it hasn't been done. So we have to rely on some other process besides Helm to get output as to what's going on. So hence why we have to, we don't have to drop Helm Atomic necessarily, but I can't see a way where we can capture the point where we can monitor the rollout unless we just get Helm to apply and then something else to monitor the rollout.
Is there any people out in the industry who are also using Helm? Have people kind of documented how they've recovered logs?
Yeah, so I've been looking at trying to figure out what other people are doing it. So this is rolled out successfully. So I'm just going to quickly undirty pre-releases.
I have one question.
Sure.
Because the way you do it, you're doing it right now is you're trying to get the details of the deployment, right? And try to list them by they are happening. Could we spin up another pipeline or another job in parallel to the Helm deployment?
So that's the, yeah. So I was thinking about that approach. I will get back to your question, Amy. Sorry, I didn't want to feel like I've forgotten it. So the problem is the race condition. If you run the rollout status command before Helm has actually applied the manifest, you'll get it, it will return straight away and says the rollout is complete, everything is updated, nothing's changing. You kind of got to kick off the change and then like run the rollout status afterwards. I haven't even looked at Helm file itself has got a way that it could fork it off like at the same time it runs Helm because it's got those exec hooks. So I do need to investigate this a little bit more. But yeah, if we could just somehow guarantee that we're like forking them both, like we definitely are running the rollout status after the Helm apply has happened. We could leave things the way they are. I still think potentially looking at what Helm gives us or doesn't give us is not a bad idea anyway, because as I said, I'm still not 100% sure if its monitoring of problems is as good as we potentially think it is. I know they've removed large chunks of code related to determining if things succeed or fail around other things like services and load balancers and stuff, because all the different implementations had their own different quirks and Helm kept on tripping up on them. Like Helm was trying to figure out if something was successful or not, and they couldn't because of the different quirks of different providers. So they started rolling back a lot of the Helm detecting if something has succeeded or failed. But for pods and deployments, which you think are a very simple, concrete concept, you would hope it works. So yeah, I think as part of this, I definitely want to just test what we currently have and, you know, even just capture like, yeah, if I fat finger a config setting or a, you know, an image thing, does this actually pick it up and roll it back, and how quickly is that? And yeah, Amy, to your question, so there's a few, basically, honestly, a lot of it is custom tooling. So a lot of it is people just write their own kind of, I've put on the issue, there's like 6 or maybe less, maybe 4 different like tools I've found that people use to like basically wrap around the client, the Kubernetes client libraries to provide like pretty output of things changing. And a lot of bash scripts that just wrap kubectl rollout status, or there's another command called kubectl wait. So that's, yeah, it's the other big thing to note as well for this is a huge part of the larger community now use the quote unquote the GitOps operators. So that's Flux CD and Argo CD. And those are like, you have an agent running, like a giant piece of software, a software agent running inside your cluster, and it pulls the Git repo down. And you can define, there's a Helm release in there, so please run it. And so it's running Helm, but it wraps Helm and basically does its own logic. So Argo CD has this concept called Argo rollouts, and Flux CD have their own kind of so those software products have their own monitoring system for how they determine to roll out or Kubernetes objects are complete, and that's agnostic to Helm, because Flux, for example, or Argo, for example, supports Helm, JSON, and all the other things, and they just wrap it up in a nice little package with a pretty GUI. It's actually, honestly, for what we do, it's actually kind of cool. Like they do like all sorts of like auto canarying stuff, promotions built in, like promotion concepts, first class citizens in the application. So it's actually kind of cool piece of technology, but it is different in that you're no longer using CI to deploy. You just merge in your CI, like your CI or your Git system just merges, and then it's the controller in the cluster that rolls that out. So it's just, and that is like very, very popular, like very, very popular now.
Yeah. What happens now, assuming we implement this and we get rid of Helm rollbacks and Helm atomic? What happens when I retry failed deployment? They'll just fail again, right?
Yeah.
Or will something else happen?
No. So so to be clear, when you say retry failed deployment, you just, let's say you just ran KCTL apply again. Yeah. Yeah, it should just do the same thing.
Okay.
Oh, actually,
I'm just wondering, like, because I thought it'd be different, right? Because previously, my understanding was Helm was rolling back, so then it would try to reapply the bad change again, and it would fail again. In our case,
so no,
failure has already been applied. So would it just be like, would it be a clean
nothing would
pipeline?
happen. It wouldn't even run Helm. So you're right. It would not. It would say there's no differences between.
Yeah, this is concerning for me because,
sure,
right? Because your first instinct is always to retry. You know, and then be like retry, and then there's like no change, you know, and then maybe even our pipeline would proceed.
And
right?
Yeah, you're right. And to be fair, and once again, this is a big if you're in the process currently with Atomic and you cancel that job, like while Helm is waiting, and if it doesn't pick up and roll it back, we're in the same problem. Like, yeah, I really need to, I think as part of this, I should do some proper testing investigation of what the current state is in terms of failures. Are we picking them up? Is Helm picking them up? How long they are? Because I don't know. I feel like there's a lot of times where it's like, oh, this is taking a long time. I see the problem. This is crashing or not working. And I've had to cancel the pipeline and Helm just hasn't picked it up. But I don't know whether it's just been like, maybe it can take crashing pods, but not crashing init containers. Maybe it's stuff like that. So honestly, this exercise, although it's growing in scope a little bit, is probably worthwhile in understanding. Like all of this is just around how do we understand if a Kubernetes deployment is progressing or failing, and what we do with that. So even stepping away from technologies for a second, maybe just capturing, possibly even doing a run book on this, maybe of just like, how do we determine, you know, what is the tooling and pipeline that determines something succeeding or not, and what to do.
Yeah, I think that would be really useful to go through. Like, feel free to just put it all in an issue or something for now, and we can pull out the bits that end up being, you know, we need to know. We can have run books for those bits and some other kind of tooling things, but it would be good to understand, yeah, where things are.
Yeah.
What's the kind of theory at the moment then on k8s workloads versus deployer, now that we have virtually everything migrated?
Well, I mean, last night there was a discussion of how do we feel about GitLab com infrastructure and k8s workloads as well, right? Like, so
what was the answer?
Monorepo all the things, I think was the answer. I totally see us triggering k8s workloads from release tools, right? That's the direction we're going to go, I hope, where as we move things to Kubernetes, deployer becomes smaller and smaller. And really deployer right now is only doing migrations, post-deploy migrations, pages, Giddily, right? So maybe release tools does the trigger to k8s workloads.
Yeah, I think that's probably right, and that's kind of where so we have a lot of kind of logic and process built around deployer. So I think it'd be really good to do a comparison around how does that map to k8s workloads? Like what are we missing? What do we gain? What's different? And then solve this like as a kind of a like delivery problem rather than as a Kubernetes problem.
Yeah, I mean, that's the interesting thing where lines blur, right? Because like k8s workloads is interesting in a little bit because it is now like and someone can correct me if I'm wrong, this first intersection of like just SREs doing standard infrastructure work. I just need to change this config or whatever, versus the intersection of we are just delivery is delivering code and delivering code updates for GitLab, the application. But now they're kind of blurred, right? Because before, I guess you could, with Chef, you could just run it, like your Ansible would just go on the host and update the package or whatever, and it was separate to like whatever else is going on. But now they're actually in the one repo and they're kind of
You've got an interesting, like, again, we are not the first person to handle this, but it's definitely an interesting one where we're kind of dealing with two layers at the same time, right? Because you can change the config and you can change what's running on that config. So
yeah,
I mean, from a growing into a bigger company and needing more kind of confirmation around this stuff, they should probably both go through the same level of tracking and documentation and approvals and things. But there must be something like, it's not a great idea in the concepts of continuous delivery of small batches and being able to quickly identify what you change. It can't be a great idea to be changing your config at the same time as you're changing the code running on that config, because when something goes wrong, like where do you start looking?
Yeah. Well, we've got the protections so that doesn't happen, right? Like we do have k8s workload. I mean, this is the other. We've got a lot of, not craft, but we've built a lot of stuff around k8s workloads related to, because that's the problem. Like at the moment, we have a lot of bits and pieces and scripts and stuff in there to make sure that someone doing a config change is not trampling or fighting with someone doing a delivery change kind of thing. And
what about a theoretical? So like everything in our CI pipeline at the moment is jobs, right? And so we handle the dependencies between like Gitly versus Rails and deployment migrations and things as different stages of the pipeline. Is there a way that we just add to that so that we have, when we roll out a deployment pipeline, like the first stage is apply config changes, and then maybe there's some testing or whatever, and then we apply code changes on top of that? Would that be possible?
So you're saying that, like, so if I want to make a config change, you're saying that now becomes part of an auto deploy pipeline?
Yeah, exactly.
So there's no like, so the only like any change just comes in part of like our continuous delivery pipeline, full stop.
Yeah, like thinking in the future, like imagine this is a continuous deployment, like fully automated with like testing and like rollbacks and things in place. Would you want config to be running on a separate pipeline? Because it seems like what we struggle with a lot is the conflict of these things colliding. So wouldn't
sorry.
Yeah, go for it.
I was kind of thinking, or maybe flipping this around, why can't release tools using the API submit a merge request for a version bump in k8s workloads? And we use something like merge trains, which sort of gives us what we want, right? Because we want to queue up changes that are both either application or config differences. So instead of triggering a CI pipeline with a CI variable that overrides the image version, we just have everything in Git. And instead of triggering a pipeline, we we submit an MR over the API and merge that MR over the API. And so everything is going through MRs to mainline. Would that work?
I would love that. Yeah, I think if that was possible to do, I think that would be great, because that gives you the Git history of when image bumps happen.
Yeah.
Because at the moment as well, with the CI variable approach as well, we've got the problem of, not even a big problem, but like we want to get more what you see is what you get. But at the moment, we actually use Helm file to call back to Kubernetes to get the current running version of something, unless it's an audit. Like we do some strange loops to actually kind of, so people can so the Helm can reconcile. If I'm not doing an auto deploy, what's the version of GitLab I'm running? I don't know. I'll go and check what the current version is and just use that kind of thing. Whereas if it's all in Git and it's just in files, like you can see clearly a Git history. And then
I don't know.
also,
yeah.
and then also, wouldn't that mean rollbacks, at least from the Kubernetes side, would just be a Git revert?
Yeah. I don't know
And then
why
merge that.
I don't know why we were so set from the beginning on using pipeline triggers. I think it's because we've done that in other situations, but I guess it would be just as easy for us to use the API, update the file with the new version, update the values file with the new version, submit an MR over the API, and merge that MR over the API. And we could do that all from deployer or from release tools, right?
Do you mean for all changes or config changes?
For but well, so
For
we have two
auto
categories,
deploys.
right? We have like
Yeah,
config
right.
changes, which require usually a manual review, and then we have auto deploys, which need to be automated. But in both cases, we would just use MRs. And for auto deploy, these MRs would be opened programmatically and merged programmatically.
How would you maintain the order? Like, would we just trust that Git can maintain that? Because
So this is where I was thinking,
the challenge
yeah.
is like the forwards and backwards compatibility, right?
Yeah, I mean, this is where I was thinking maybe merge trains could work, because this queues up changes, you know, that need to be merged. So then, yeah, you do have this problem where you could have people stepping on each other, like.
Because one of the benefits of a pipeline is it's kind of a contained, it's like a transaction, right? You say like, for this period of time, we guarantee we're going to do job 1, 2, 3, 4, 5 in order.
But that's the problem.
Yeah.
We don't at the moment. So at the moment, to be clear, we got resource locking on individual environments, but not for a whole pipeline.
Yeah,
So,
for jobs. Yeah.
Yeah, for jobs, not pipelines.
Yeah.
So a config change, and I think I've done this, I think others have done this before, definitely just through bad timing. A config and a auto deploy
come in
actually
sort of sideways.
overlap.
Yeah. This is kind of what I'm saying about somehow they
yeah.
need to be tied together, right? Like I don't think these things should exist as separate processes because of that. Like I think what we don't have a way of at the moment, like at the moment we have the problem. We must have incident where something happens, so we see something strange, and we've recently applied some config changes, and we've recently deployed some code. Like it's not clear where that comes from, right? And that presumably increases in the future.
It's almost like, oh, go ahead, Graham.
Oh no, sorry.
I was going to say, it's almost like you want something like a lock on the pipeline. You would lock it on release tools. Say, I'm going to make a config change. I'm going to lock the pipeline, and that would stop all auto deploys. I'd make my config change, and then I would unlock it.
Why would you want to lock it though? Like, because say, assume in the future when we achieve small batches, like, wouldn't we like? My kind of assumption is we will have so many of these things in the future that you would want to have kind of like, 5-minute config changes going out, 5-minute code change, 5-minute config change, code change, like it's really quick and rapid.
Mm-hmm.
So in that case, really what we need, I wish Alessio was here, because he was telling me about this as well. He had some ideas on this, because I was telling him about the whole lock a whole pipeline. He reckons there's a mechanism you can use to like, basically you just have a pipeline that's one job to spawn a child pipeline, and you can lock that job, and therefore you kind of more or less lock your whole pipeline.
Isn't that what the coordinated pipeline is doing?
I possibly, yeah.
Because that's what I mean. I wonder if there's like a stage in there where we apply config.
So, walking even back from that, right? Like if we just, regardless of any other change now, if we can make it somehow that k8s workloads pipelines, the whole pipeline never crosses, so they all back up regardless of config or auto deploy changes, that's probably pretty good, right? Like if the whole pipeline end to end can never overlap, that probably gives us so much more safety right now than what we currently have.
Yeah, I think right now, I mean, we lock at the job level, so that you can interleave changes. For example, you could be doing QA on your staging environment while a change is being deployed, and we probably don't want that, right? So we want to lock at the environment level, and if we did everything through MRs, where an MR, like starting an MR would lock it, and then it's not until that change has been fully applied, then it would be unlocked. Then I think that would solve the problem.
Interesting.
Yeah.
So I think, Graham, you've got a fun task ahead of you, which is, I think it would be really interesting to actually do a comparison of what are we doing at the moment, k8s workloads versus deployer, and then say in a year's time, how do these things come together? And then we'll get some that will help us decide on kind of next steps for the Helm logs.
Yeah. So yeah, fair enough.
Because I think these things are going to have to come together. Like, assume we say double the number of engineers working on all of these things, we've got a lot more changes coming in on both of those pipelines.
Yeah. So it sounds like also I probably need to spin up an issue, like a tech debt issue, around just we need to make the k8s workloads pipelines fully pipeline locking. Like that's a discrete small task we can do, I think, orthogonal to everything else. Even if we can have the k8s workloads pipelines at the moment never overlap for whatever reason somehow, I think that's a good discrete change we could do. That gets us some value, because at the moment we do interleave and there's potential for problems. Then there's a separate issue of trying to get some visibility back in deployments. And then there is the separate issue of what does k8s workloads currently do versus deployer? What's the safety and rollback process around that, and what have you. So the thing with deployer too is, like, so does deployer actually do rollbacks, like automatic rollbacks? It's only manual, right? Yeah, right.
But we're working towards that. And this is where we should pull this stuff all together, right?
How do you determine an automatic roll? That's what I'm curious about. Maybe that's a larger discussion. Like,
I'll send you the epic.
Yeah, how does deployer make the call that something needs to be rolled back? Because it's the same problem I've got with Kubernetes. I'm like, how do I make the call? There's some very simple basic things I can do, like if a pod is crashing, roll back. But there's a lot of kind of, I mean, it depends on how much deep you want to go into it, right? But
yeah, let me send you the thing. So it builds on what we have at the moment, but there'll need to be some kind of health checks and metrics added in.
But yeah, anyway, this is good. I will, I'm going to be, wrong one. I'll definitely continue on fleshing this out and understanding what we currently have, and then trying to figure out what we want to do moving forward to get some visibility back. Because I think having something where we can see what's happening with the deployment is good. Because at the moment, you basically have to get on a console server and start looking around. You don't know which pods are even crashing, what have you. We don't monitor jobs at the moment. Well, Henry's here as well. Okay, so 100%. Helm does not monitor job success. So we use jobs for the registry database migration. Helm will happily say thumbs up, green tick if the registry migration job is just failing. So, and they've made a conscious decision to not support monitoring jobs. I think there might be a flag to do it, which we don't have set. So maybe that's the solution. But once again, we need to understand with those migration jobs, because at the moment it's deployer that's currently doing migration jobs for GitLab, I believe. Is that correct?
For registry or for GitLab?
For GitLab.
For GitLab, yeah, that's the deployer doing this in Ansible.
So this is going to be the first system where we're not using deployer for handling migrations, and we're doing it in Kubernetes. So it sounds like then that we need to understand that and get a handle on that. But potentially, if we do that right and get a handle on that, then also it means we could actually move GitLab migration jobs into Kubernetes as well, and that would come out of deployer potentially if we got that into a good state.
Not sure where the plans are for that. I think the distribution team thought about this a long time, and I think they have some ideas about how to do this, but I think for good reasons, we stayed with a separate approach to have control, right, for database migrations.
Oh yeah.
Especially if you want to roll back and things like that. And so
so then the question is, why is registry different? Not trying to say like
I think that was the easiest solution to do this, and this will also be the solution that customers are using. Like for our customers, they also use K8s DB migrations, I guess, normally. But in our complex setup with a lot of parts and pieces, I think we decided to do it separately. And for registry, it was easy to just use the mechanism that was already in our charts for DB migrations. And it's easy because we didn't have the case of complicated post migrations yet. So we always have pre-migrations. And so it's easy to just run the job and then run the deployment. And you just have to make sure that you have some kind of version compatibility so that the old and the new deployment still can work with the migration. So this is fine for now. If you should have
I'm just curious
coming up, then it's getting more complicated, probably.
Yeah, I'm just curious as like, okay, we're doing some migrations in Kubernetes and then we're doing some migrations in deployer, which is, I was just more curious as why we chose different ways. And it sounds like realistically, if we keep registry migrations in Kubernetes, that's fine. But then as part of this, we need to make sure that pipelines are failing, or we've got some kind of because at the moment there is zero monitoring if those jobs fail. Like nothing, no pipeline will fail, nothing will.
I saw when we had pod crash loops because migration is not being successful for registry. Then we got into maybe pod crash loops, and then after a while, Helm would just roll back.
Maybe it's because the actual registry pods detect whether the migration hasn't been done and then crash out. Maybe that's what's saving us there.
No, the issue that I saw, I think, but I'm not totally sure, is that if the DB migration job failed because it couldn't connect to the database, for instance, then this job failed.
Okay.
And then it was tried again and again and again with a backoff. And so on. And after a while, after an hour, Helm would say, oh no, I can't get forward, so I will roll back. So that's what's happening. So that protected, I think, registry from rolling forward.
Okay. So I guess two things there. So maybe I'm wrong. Maybe Helm does monitor jobs. I was pretty sure it didn't, but maybe it does. And B, back to what I was saying earlier about Helm not rolling back. I was wrong. It does roll back after the timeout. So that's the problem. Helm Atomic will roll us back, but it waits an hour. So we have to crash loop for like an hour or whatever our timeout period is before Helm rolls back. It's not that it didn't roll back. It's that it takes a long time to pick up the problem and roll back. That's what the problem is with the current state. Which I think we want quicker, right? Like, correct me if I'm wrong. We don't want to, we kind of, as soon as a pod's crash looping for a bit, we kind of want to roll back straight away.
Yes, that would be nice, of course, yeah.
Awesome. Okay, great stuff. Is there any other stuff people want to go through? Nope. Okay. Fantastic. Thank you very much for the discussion. Graham, feel free to put some several issues with these sorts of topics. Don't feel like you have to work out how to structure them together and things. So I think we need to pull this into like the slightly bigger, in a year's time, what does this sort of stuff look at? And then we can tie the short term into that. Awesome.
Sure thing.
All right. Well, I hope you'll have a good rest of your day. Speak to you soon.